You can even go to another extreme. For the random forests, you had trees that were not that deep. It was, I don't know, uh, the depth of the tree was 2 or 3 or 4 or even 10. You can go to the extreme. You can have a tree with only 2 branch and 1 layer deep. You can have a tree like that. These are very weak classifiers. So you look at one feature at a time, and then you just divide it into two, left or right. Okay, so these are very weak uh, classifiers, but then we are going to combine them together. How are we going to combine them? And that the method is going to be AdaBoost. It's a boosting method. You start with your original data. Some of them are positive cases, some of them are negative cases. And you can see that the decision boundary is complicated. So this is going to be your decision boundary for classifying. You can have a tree with only 2 branches, and what it's going to do is look at maybe this feature. So this is going to be our feature, and based on that, it's going to divide. It's going to say, I'm going to draw a line here. Anything above this line is going to be negative. Anything below is going to be positive. And then for sure, this method is going to make a lot of mistakes. So these are the mistakes. It made a mistake here. It's classifying the plus as a minus. It's classifying these two minuses as pluses. What we are going to do next is try to focus on these mistakes. So these are going to be your hard examples. You go and adjust your training data. You increase the weight of these data. Perhaps you can sample from them more, or you can just increase their importance. So you increase their importance, you increase the importance of this data, you increase the importance of this data point, and you increase the importance of the other data point. And then you're going to use another weak classifier to classify these. So let's say now your classifier is going to choose this feature, the second feature, draw a line, and then does its classification. It's going to make some mistakes. This is a mistake, this is a mistake, that's another mistake. For the next iteration, we are going to give more importance to these data points, to these examples. And then you keep doing that. Another weak classifier, very weak classifier, going to do some classification, and let's say at this point you stop. And let's say, okay, you guys, this guy, and this guy, vote. And they're going to vote for you. The first classifier is going to vote that this should be my line. The second classifier is saying this should be my line, my decision boundary. The third classifier is saying that this should be my line. So that's here. And when all of them vote, you're going to get a complex classification scheme in the end. And that's going to be your complex decision boundary. So anything to the left of this boundary is going to be classified as positive. Anything on top anything to the right of this decision boundary is going to be a positive. Anything to the left of this decision boundary is going to be negative. And then you're classifying most of your examples correctly. In this case, all of them are being classified correctly. So that's the idea of AdaBoost in general. In your higher level classes, you're gonna into more details of how to implement this, what is the math behind it. It's not that complicated actually, but that's the general picture. It has 2 steps. One is updating the importance of your examples, and then the next one is doing the weak classifier. And these classifiers are just trees. It's a tree with only 2 branches. That's it. Any questions? So the library that you can find this method in is GBM. And then we are gonna do what I just explained is for 2 classes. You can generalize that method for multiple classes. It's gonna be much harder, but it's doable. You can generalize that to multiple classes because in our diamonds data, we have 5 classes. We have 5 categories for our cut variable. That's why we need to specify the distribution. This one is gonna take some time. And then once everything is done, you can print the model, you can do your prediction, and it's using 100 trees, 100 very weak trees, decision makers. You can look at the confusion, and that's the accuracy. Any questions?